Namaste. In this video, we are going to be reviewing the types of angles. Remember that a right angle measures 90 degrees. An obtuse angle measures between 90 and 180 degrees. An acute angle measures less than 90 degrees. A straight angle measures exactly 180 degrees. And a reflex angle measures between 180 and 360 degrees. Throughout this video, you will encounter several practice problems dealing with these types of angles. We're asked to match the following. I encourage all of you to pause your videos and try this one out. So let's get started. For our first diagram, we have an angle that appears to be greater than 180 but less than 360 degrees. Remember that 180 degrees looks like a straight line and 360 degrees looks like an entire circle. So what kind of angle is that? Remember, that is a reflex angle. So for our first diagram, we can draw a line to reflex. What about the next diagram? This time, we're given that it measures 30 degrees. Remember that an acute angle is between 0 and 90 degrees, and 30 falls within that range. So our second diagram would be considered to be an acute angle. What about the third diagram? This time, we see that it's equal to 180 degrees. Remember that anytime you are dealing with 180, you have a straight angle. Straight angles always are straight lines. So this is a straight angle. For next diagram, we have a 90-degree angle measure. And in addition to that, I also see that we have this small symbol. Right away, I know that's a right angle. And for our final diagram, notice how this angle appears to be less than a straight angle, but greater than a right angle. So therefore, it is an obtuse angle. For our next set of practice problems, we will be dealing with complementary and supplementary angles. Remember that complementary angles are two that add up to 90 degrees, and supplementary angles are two that add up to 180 degrees. So between these two diagrams, which one is complementary? Well, to me, this one looks complementary because I see that it has a symbol that appears to look like a square, which indicates that it measures 90 degrees. And the way that I know that this diagram is supplementary is because LN is a line. So therefore, you can assume that it measures 180 degrees. So let's get started with the first diagram. I have that one of my angle measures is 76 degrees and the other one is x. So how can I solve for x? If you watched my previous video, you'll know that we need to set up an equation. So to do so, we can say that x plus 76 equals 90. And by subtracting 76 from both sides, we get that x equals 14 degrees. So that's our final answer for this first problem. For our second one, we're going to be doing something similar. I have to set up an equation, except this time I'm dealing with a supplementary angle, 180 degrees. So I can say that x plus 66 equals 180. And by subtracting 66 from both sides, I get that x equals 114 degrees. We are now asked to label this diagram. And before I do so, there are some terms that we should review. The first one is vertex. Remember that a vertex is the intersection of two lines at one common point. So, for example, I can construct a vertex by simply drawing two lines that intersect at this dot. So that is a vertex. In our diagram, the vertex is considered point O because that is where AO and BO intersect. So we can say that number 3 is the vertex. Okay, what about numbers 1, 2, and 4? Remember that lines 1 and 2 are special types of lines called rays. And rays are lines that have one endpoint and continue on forever in the opposite direction. So for example, a ray could look something like this, where this is the endpoint and it continues on forever to the right side. So in this case, we have two rays in our diagram. One of them is OB and the other one is OA. So therefore, number 1 is a ray and number 2 is also a ray. What about number 4? Notice how it's pointing to this entire angle measure. So we need to name that. Remember how we name these angles is by the order of which these points are written. So we go B and then O and then A. So for number 4, we can say that it's equal to angle BOA. For our final practice problem, we're asked to construct and label a shape with perpendicular sides and right angles. Let's recap what each of these are. So remember, when two sides are perpendicular, they intersect at right angles. So an example would be the image that I just drew. We can say that one of these lines is perpendicular to the other. And right angles are these small figures over here that represent one of these 4 intersection points. So how can we construct a shape that has both perpendicular sides and right angles? Well, there are multiple. And if you think about it, I could construct a square, a rectangle, or a right triangle. So let's look at an example of a right triangle. Remember, a triangle has 3 sides. So if I wanted to construct one that was perpendicular to the other, I could do so like this. And in this diagram, the way that I would label perpendicularity is using this small square looking symbol.